Hello and welcome to this SPLC 20 paper presentation, Product Line Adoption in Industry. This is an experience report from the railway domain. I am Muhammad Abbas and I work together with Mehrdad Sadatpant in the Research Institutes of Sweden in Västerås. Robert Jongling, Edward Paul Inoue, and Daniel Sundmark, they work in Mälardalens University in Västerås, Sweden. Claes Lindskog works in Bombardier Transportation as the lead of propulsion control software. To introduce the context of this study, we need to see why Bombardier needs a product line and what is the variability inside these products at Bombardier. So Bombardier developed trains. They might have different seat capacity requirements with some speed requirements, which would change the hardware, which would result in a different software to handle that particular hardware configuration. Type of power is also a source of variability. Bombardier tries to target all these market segments with different products. Another source of variability is that the same product might be running different software in different regions due to regional standards. At the heart of all these systems is the propulsion control software. The team at the company wanted to exploit the commonalities in these products and go with a software product line engineering process. They successfully exploited these commonalities and adopted a software product line engineering process. And we wanted to see what practices they are following and what are the open challenges in this area and what is the future vision of the company regarding their product line engineering process at the propulsion control software team. So this study is focusing on that. So the product line engineering adoption is inherently a complex and expensive task. In the literature, there are different strategies to this adoption. Big Bang adoption strategy drastically changes the processes inside the company towards product line engineering process. In contrast, incremental and pilot project-based approaches allow this adoption in small increments. Companies are not often willing to pay high cost for the product line adoption. So if you look at the return on investment of the product line engineering, if the black line is product line engineering and the dash line is the single product development, companies often try to end up somewhere in between to reduce the upfront investment in the product line engineering. That leads to unsystematic reuse processes and evolutionary development of the product line. So in the study setting, the SPL is realized by overloaded assets. They are developed in evolution. And the reuse process here is a clone-and-own way of reuse. So in this setting, we wanted to improve the current practices of product line engineering in the company. So for this, we first reported the current practices of the company, and then we defined research questions to collect data about experience benefits, perceived challenges, and future vision of the company regarding their product line engineering process. To collect data relevant to our research questions, we used mixed method research, document analysis, and focus group. So we analyzed the company documents and develop a process map of the company regarding their process of software product line engineering. That was later verified by two managers at the company. And that resulted in reporting the current practices section in the paper. In addition to that, we used a focus group research method. So we draft an instrument for the focus group, which we refined over several iterations, and then we conducted the focus group session using the questions in the instrument. The focus group was transcribed and thematic analysis was conducted following the standard guidelines. Moving on towards the results, the current practices are that the product line is realized by overloaded assets. So if you look at the product line in the derived products, there are parts of the asset removed in the derived products, and since they are following clone-and-own way of reuse, some assets or parts of the assets could be changed too. The development of the assets is evolutionary, and new features are added when needed. That makes the derived products based on different versions of the baseline. So for example, if the product line is developed over time you would get derived products that are based on different versions of this product line. At the requirements level, what happens is that there is a generic domain requirements document called FRSP. When a new product has to be derived, they get customer requirements from other team at the company, and they tailor the standard FRSP to reflect those customer requirements. A reuse analysis is conducted to see if they have something similar implemented before in existing projects. So they look into the existing customer requirements of the existing derived products, and that result in a project-specific FRSP. At the development, what happens is that this standard FRSP is imported into Simulink requirements, and they are linked to these assets, which are Simulink models. The assets or the Simulink models are basically a combination of a subset library, a called BT subset. And when a product has to be derived, the FRSP is tailored, and the tailored FRSP is also linked to the tailored assets of the derived product. All the artifacts produced in the development are tested at different levels. The units are tested, the combined units are tested at the component level. The components are combined in such a way that serves a system function, and that are tested at the integration level. Finally, there is a system level test too. All the products are tested in different phases. First, the model is tested, code is generated from the models, and the software in the loop testing is conducted. The generated code is deployed on a processor, and a processor in the loop testing is conducted. Note that the environment and some parts of the hardware are simulated through plant models, and these models are never reused across products. Moving on to the results of the focus group, we would focus on some sub-themes and codes. Saving time and resources is one of them. There has been a reduction in development time. Before, it was taking around 1 year to develop a new product. Currently, the product derivation time is around 1 month. There has been a reduction in producing new test cases. Before, it was around 8 hours for one test case, and now it's 4 hours. There has been a confidence boost in the derived products. That is because you build a knowledge base throughout the years that you could reuse in the future products. In addition to the experience benefits, there are also several perceived challenges. So, for example, in the product derivation, identification of the reuse opportunities at the requirements level for the product line assets is seen as a challenge. Over the years, they have done a lot of derived products. There are a lot of functional variants of the same assets. So when they get requirements for the new product, they need to know what functional variants of the assets and what assets could they reuse from the product line to realize those requirements. Change propagation is also seen as a challenge. It's over the years you do a lot of improvements and enhancements to the standard product line. Should you really propagate them to the derived products or not? One of our co-author has a paper accepted on it in models. Impact analysis of test cases is also seen as a challenge. So you have an asset coming from the product line with some test cases. When you modify it in the derived products, what would happen to the test cases? Can you reuse some of them? Would the test cases break or not? In addition to that, one other sub-theme is the software product line engineering awareness. In the studied setting, the company is really project-based company, and they have to think product-oriented. This is seen as a challenge. This also leads to some architectural decisions which are negatively impacting reuse. Particularly, the integration between the assets is really hard to reuse in the derived products. So in addition to the challenges, we also identified several improvement opportunities. Automated verification is one of them, and when the team tried to apply model checking, for instance, they found several components with dead code. So these approaches could really help the current practices improve. Also, the test efforts could be reduced by reusing test cases between different phases of testing, like software in the loop, model in the loop, and so on. And then, since they are following a clone-and-own way of reuse, test repair approaches could be really of interest. For example, when you have an asset coming from the product line with test cases, and this asset is modified in the derived products, could we somehow automatically repair the test cases too? Finally, some Other areas of improvement could be the artifact evolution. As mentioned, test case evolution is one of them. But traceability link recovery between the requirements and model elements, and traceability link recovery between test cases and model elements is of high interest to the team, because currently all this is done manually. The future vision of Bombardier regarding their current processes is that they want to bring in more variability aware approaches for test case generation. In addition to that, they want to come up with a regression suite for the entire product line. Regarding the development process, continuous integration is of high interest. Continuous delivery and deployment is of very low interest because of the safety critical nature of the product. They want to have separate domain and application engineering teams. To summarize, the product line adoption at the propulsion team in Bombardier was quite successful because they followed this evolutionary and incremental manner of adoption. There are no separate teams for domain and application engineering, but this is the future vision of the team regarding their product line engineering process. To summarize the results, there has been reduction in development and testing time, but in addition to these benefits, there are also several challenges that came as byproduct from the clone-and way of reuse. There is a need for tackling these challenges. There is a need for approaches to tackle these challenges, particularly in test reuse, co-evolution of the assets, and co-evolution of the test cases. Test generation and delta testing is also of very high interest to the team. It has been really great working with Bombardier, and in future we are working on solving some of the challenges in the current practices. Thank you for listening. If you have any questions, please email them.